In this video, we're going to give you an overview of the tool database in the software and how to manage your library of tools. First thing I want to show you is how to access the tool database. We need to have a new file or open an existing file. So here I'm just going to click create a new file. We'll go ahead and just take the default settings that I've got there, they're not important at the moment. And then we need to go over to the toolpath tab. I can do that either by hitting the shortcut key F12 on the keyboard, or we can click on the icon here. That'll do the same thing, which is to minimize the design tab on the left and open the toolpath tab on the right. The tool database can be accessed through this icon here, which if I click on it will display the tool database to me. You'll also see later how we can access the tool database through the select button within each of the different toolpath strategy setup forms. The tool database window is effectively split into two areas. On the left here we have our tool list, which allows us to organize our sets of tools into groups. If I open one of those groups, you can see the individual tools contained within it. At the bottom of that list we have a set of commands on the buttons here which apply to that list, and we'll run through some of those in a moment. When we select any individual tool, on the right we see the tool info area is now filled with the information that relates to that tool. All this can be edited and changed, and hitting the apply button in order to move on to another tool within the tool database if I wanted to. And then ultimately at the end of that, if I hit OK, it will save any changes I've made and close the window. If I hit cancel, it will discard any changes I've made and close the window. It's also possible for us to come over in the bottom corner here and expand or reduce the size of the tool database window as well. So coming back over to the left hand side, you can see the tool list and how this is organized into groups. These groups can be contracted by clicking on the little minus sign next to them, so we can collapse those groups down, or if we click on the plus sign, then that expands the groups. By default we have a set of imperial tools and then subgroups divided up by tool types, and the same for metric tools. It's important to note at this stage that you don't have to use this default set. You can define from scratch completely your own set of tools, or edit any of the ones here, including changing the names or any of the values within them to make a tool library that matches the way that you want to use the program. Now the first option at the bottom here is to create a completely new tool, and we'll come back to that in a moment. Typically what you might do though is take a copy of an existing tool and just edit the parameters for that in order to create a new tool. So we'll start by showing you that. Let's just expand the ball nose section here. You can see we have a 1/4 inch and an 1/8 inch ball nose, and I'm going to imagine that we want to add a 1/2 inch ball nose onto this. So I'm going to select the 1/4 inch, I'm going to hit copy, and that's going to create a duplicate of that tool there, which you can see here over on the right hand side showing me the information from the selected tool. And now what I can do is just edit the values for this top to bottom here. So let's change the name of this to be a 1/2 inch. Tool type is a ball nose. I could alter this if I was creating a different type of tool. Next we've got a notes section. In here I can type text, and this might either serve just as a reminder when I come into the tool database to select this tool of some information that I need to be aware of. Also this section can be extracted and output into the post-process file if you have the appropriate entries in your post-processor. So if you want to take information about the tool and put that into the G code, then you could enter it here and edit the post-processor accordingly. For the geometry here we need to update the diameter for this tool, so there we're going to set that to be a 1/2 inch. And for all the different tools, what you'll see is a diagram over on the right hand side here that shows a generic version of this tool that has important dimensions labelled, so that you can see exactly what the diameter relates to and any other parameters that you're entering for a particular tool. Then we have the units for the diameter of the tool here, and next we come down to the cutting parameters. This is where we define how much distance there is between each vertical pass the tool is going to take and how much distance there is between horizontal passes. The vertical passes is the pass depth, so here in this case I might edit this to take a 1/4 inch depth of cut each time it goes over a particular toolpath. So this particularly applies to things like profiling and pocketing. And then the step over, as I say, is this horizontal distance, and this typically is important when we're doing things like pocketing, 3D roughing and 3D finishing, if that applies to the program you're using. So for a finishing step over is going to be typically around 10%, maybe down to 8% of the tool diameter, and that's what this value on the right here is showing you, is a percentage of the tool diameter, and on the left is the actual physical value of that. So if we change the percentage to 8, you'll see that the step over automatically updates, and likewise if I edit the value here, then that's going to update the percentage for me. In the next section we have what's typically referred to as the feeds and speeds for your tool. First is the spindle speed, so this is the speed the tool's going to revolve in your spindle in revolutions per minute. So you can enter an appropriate value here, and if your post processor has the ability to output this value and your spindle supports the control telling it the speed to run at, then that should control your spindle for you. In some cases, a spindle or a router may not have the ability to be controlled by the machine, and it may just be a set value that you switch on the actual router itself. Next we have the feed rate. This is the speed that the tool is going to move through the material when it's cutting. So we can enter appropriate value here for our tool and the material. And the plunge rate is the vertical speed the tool will move down to that position as it enters the material before it starts cutting. Both of these can be controlled from the units drop down here, so some machines work in inches a second, inches a minute, or it may be that you're working with metric parameters depending on your machine setup. The last section here is where we can indicate a tool number. This is important if you're running a machine that has an automatic tool changer, because it indicates to the machine what position this tool sits within the tool changer. You can enter a value for this in here, or you can use the up and down arrows in order to control that value. Once you're happy with all the parameters, it's worth just scanning from top to bottom, again just to make sure things like the name and the diameter match and all the other values are appropriate for what you're planning to do with the tool. Then you can go ahead and hit apply, and you'll see that that's updated now in the tool list here over on the left. Now you can see, because of the way we've copied that and edited it, we now have these tools in a slightly odd order in our list, and we probably want to make that a little bit more logical, and we can just drag these tools around in order to change their position in the list. So here I might want to take the 1/8 inch and just drag that up to the top here so that I have the 1/8, quarter and half running in that more sensible order there. Now it may be that rather than adding or editing to the existing list, that I'd like to create new sections within my tool database. So if I come up to the top here, let's click on the Imperial Tools section and let's click on the button New Group. You see there, that's going to create a new group for me, and now I can edit that group's name here or in the list. So let's call this Vectric Tools and hit apply, and you will see that update in the list over there on the left. And now I could actually take and drag tools from one group to another if I want. So perhaps instead of adding this to the existing list here, I maybe want a special list of my own tools. I can click and drag this just into the bottom section there of the name, and that will be added now into the Vectric Tools area of my tool list up the top here. Now I can also create completely new tools as well, rather than just taking an existing one, copying it and editing it. So perhaps if we take our Vectric Tools group, click on the new button here, what I may want to add is something like a tapered ball nose tool. This is fairly common in that we might have a small ball nose tool for finishing if we do a lot of 3D work potentially, and but we want to add one that's got tapered sides. Conical cutters tend to be stronger than straight-sided cutters, particularly when going down to a small diameter. So if we click tapered ball nose there, again you can see it's going to automatically update or create a bunch of information for me that I can now come through and edit. First thing to do is give the tool a name that I'm going to be able to recognize and differentiate from the others. So for this one I'm just going to call this a 1/16 inch diameter. Make sure we spell it correctly there. And tool type is correct, I've already selected that. Again, I could enter notes if I wanted to, in this case I don't. Now if I come down, you'll see that I've got a value in here for the diameter, and what this represents is the diameter of the tool rather than the diameter of the end here. Now on this tapered ball nose I'm entering, the 1/16 inch diameters are actually the diameter of the tip, not the tool itself. And if you're not sure what these are referring to, that's when this diagram comes in handy. So I can see the diameter D is the diameter of the tool itself, the angle is the half angle, and then for the tip I'm going to have to define actually the radius, not the diameter. So although I think of this as a 1/16 inch diameter tool, I have to enter the values which are going to set this up correctly for the software to interpret. So in this case I do actually have a shank and tool diameter of 1/4 inch for this tool. The side angle is 3 degrees. And what the software is looking for here is not the tip diameter, but the tip radius. So what I want essentially is a half of 1/16 of an inch. Now if I know the decimal for that, for 1/32, I can enter it, or I could type in 1 divided by 32 and hit equals, and so now I know that that is the appropriate decimal for my tip radius, and hitting equals on the keyboard is what's doing the calculation for that sum. Next, I'm going to enter the cutting parameters. So you need to make sure these values are appropriate for the tool that you're using. In this case, we might keep the pass step something quite small, and then step over and clearance final pass step over here I'm probably going to match for this tool because of the type of cutting that it does. And again, if I was using this for 3D finishing, I'd probably aim for around an 8% and 8% step over and clearance pass step over. I could vary those, but typically that's going to be for larger tools when I'm doing a different type of work. Again, we can come down and enter appropriate spindle speeds, feed rates and plunge rates for this tool, and they're all going to vary depending on your machine, the tooling supplier and the type of material you're cutting. When we're happy with these values though, we'll go ahead and hit apply, and you can see that's now been added into my tool list over on the left here, into the group that we were in when we hit the new button. And so the same functions could be used to add any new groups or create or copy any tools that you want and make the edits to their settings. If you want to delete a group or a tool, then you would just select the object you wanted to delete and click on the delete button. I'm not going to do that in this case because I don't want to get rid of any of the tools that I've got in the tool database at the moment. When I'm happy with the edits, then we can go ahead and hit OK. As I mentioned before, if you want to discard all the edits you've made, then you would hit cancel. Now I want to show you how to add one more tool type, and that's a specialist type of tool called a form tool. Now a form tool lets me specify geometry which is not represented by any of the standard or the other standard tool types that I have in the software. So before you saw the list of options that we have, but if that doesn't represent my shape, for instance for something like an OG cutter or for something that you're using to cut molding shapes or something like that, then I need to specify that using a vector to describe the geometry for the software. To do that I need to obviously have a vector selected, so what I'm going to do at this stage is just accept the edits I've made by hitting OK. So that's going to save those in the tool database, come back into the standard software interface, and I'm just going to come up to File, Open, and from the project folder here I'm going to choose this file called Tool Database Example and hit the Open button there. And what this has got is just a vector that represents the shape of the tool that I want to add to the tool database. This is this specialist kind of OG cutter here. Now you can draw this in the software as I have here, but quite often the tooling manufacturer will be able to supply you either with a drawing or often with something like a DXF download of the tool geometry so that you can load it in the software and use that. Now what's important is when I add this to the tool database, all it's going to look for is a piece of geometry, a vector that represents only the right hand side of the tool. So I've got too much information at the moment. So I'm just going to select this vector, click on the icon here to zoom selected so that we zoom in on the selected object. Now with that selected, I'm going to click on the icon here to go into node editing. I could also hit the N key on the keyboard to do that. And what I want to do is get rid of all but the right hand side of the tool. So I'm going to right mouse click at the top here and say delete span, and then I'm going to right mouse click with the cursor on this node and say cut vector. So that's going to slice that in two. So now if I just click back on selection mode, you can see if I click on this side I've got one vector and on this side another. So I'm going to select this vector and just hit delete on the keyboard to get rid of it. So this is all the information that I need to define my tool shape. Very, very important that it's open at the top and I only have the right hand side drawn. Let's just hit F to go back to fit here. Let's click to go back over to the toolpath tab, and I need to make sure that vector is selected before I go ahead and click on the tool database icon. Now you can see because we hit OK, there's the tools that have been added to our tool database. I'm going to select the Vectric tools group again. I'm going to hit new to create a new tool, and this time I'm going to select form tool from the list. Now when I select that, the software will check that I have a vector selected, and if I do and it's appropriate, then it will populate the form for me, as you can see here. So what it's going to do is just pick up some generic values, and it's going to show me again a little diagram of what that tool shape is going to look like. And now in the same way that I have before, I need to start at the top and work my way through to enter appropriate values for this tool. Now the diameter of the tool is picked up from the vector that I've drawn, so that will be correct, and that also helps populate the name at the top. I may want to edit this though, so we call that OG 2 inch, tool type form tool, diameter is correct. Pass depth here again I can set to be an appropriate value, and the rest of this information is typically once again going to be supplied to you by the tooling manufacturer, perhaps for a range of different materials. In this case I'm not going to really enter or change any of the values I've got here. I'm just going to take the defaults because I don't know what the actual correct values would be for this tool. I can hit apply, so that's added to my tool database list, and hit OK. Now the nice thing about these form tools is the software will represent their shape when you come to do the toolpath preview. I would like to create a quick toolpath here just to show you how that works. That also gives us an opportunity to look at the other way that we can access the tool database. So far you've seen me access it through the icon here, but if I go into any toolpath strategy, so I'm just going to select this square vector here, I'm going to click on the profile toolpath, and in any toolpath strategy you'll start with the cutting depths at the top here, so I'm just going to enter a value of 3/4 of an inch for that, and next we'll come down and you'll see we have the area where we can select our tool. And if I click on the select button, the software is going to open the tool database for me, and from the library I've got here I can choose any tool that I want. I can make edits to it still, so I can still make changes just as we have been accessing the tool database through the icon, but typically what you do is select the tool and hit OK, and then if you want to make changes, particularly if it's just for that toolpath, then you're going to hit the edit button, and that allows you to override some of the parameters from the tool database just for the purposes of this toolpath. So when you click on edit and make changes, that's only going to be remembered within this toolpath itself and will not make changes to the tool database. So next time you choose from the tool database, the tool will be as it was originally when entered. So here I could make additional edits if I wanted. Perhaps I could afford to use a larger pass depth in the material I'm cutting and go ahead and hit OK. In this case I'm going to machine on the vector that we've got here and take the default settings and just hit calculate. The software's telling me I haven't got a thick enough piece of material, so let's just hit OK, close, and change my material setup there to be 1 inch, hit OK, and just recalculate all the toolpaths. Now if we go into the preview and just take a look at this, all I really want to show you is the fact that when we preview that, we can see the tool shape being represented in our preview there. So you can see that OG shape that we've entered is being shown in 3D when we animate the tool using the preview option. Let's go ahead and reset that and close. Come back into our 2D view here. The last option in the tool database window, if we click back on the icon here, is the ability to import and export an individual tool or groups of tools. In this case, if I wanted to take the tools we've been added during the video, I could select that group, I could hit export, and that will allow me to save a file here. So I'm going to just call this Vectric tools and hit save there and OK. And in fact, let's actually just pop that up now and delete that whole group there, so it'll just check that I want to do that. And now if I select Imperial Tools, I could import that group, choose it and hit open, and you can see it's just added that back in there. And I could have done that on another copy of the software, exported across, or even if I wanted to share tools with somebody else who has a similar set of tools and is interested in the parameters that I'm using. So easy there, just select either the group or an individual tool, export and save, and then to bring that into another copy of the software we can just use the import button there. Last thing I want to show you is where the tool database is kept within the PC itself. So every time I hit the OK button here, the software is going to save the tool database in that state that we've created there. Now if we go up to File and come down to Open Application Data folder, you'll see that this opens a location on the PC, and this is different depending on the version of software that you're using and also the version of Windows you're working with. So it's always best to access it through that File drop down, Open Application Data folder, and within here you'll see that there's a folder called Tool Database. If I double click on that, you can see this is the tool database, and any edits I made will be saved into that location there. Very, very important that you back this up after you've made any changes to it, so that if you needed to uninstall and reinstall the program, or you're updating to a new version of the software, that you'll be able to load your tool database back in and replace the default that you've got there. At any stage, if you want to go back to the original set of tools that you had when you installed the software, you can just make a copy of this second file here and rename it back to the name that you've got at the top here, and the software will take that updated version. Also important to know that you should do this while the software is not running, because it can only update it once the software starts again and it looks in this folder to find the tool database file. So very important that if I did make change to these files, if I copied a new tool database in here, that I did it with the file with the software shut down, so that when I brought that in, started the software afresh, it would use whatever tool database that I put into this folder here. And that concludes this video on working with and managing the tools in the tool database in the software.